Dividing polynomials. There are two different methods for dividing polynomials. The first method is long division. Before we divide polynomials by long division, let's review the long division you learned in elementary school, since the steps are the same. So I'm dividing 4,392 by 7, and you set it up in the little long division notation. And I look at the 7 and the 4. 7 won't go into 4, so I move over and make it 43. 7 divides into 43 6 times. Now think about the steps you're taking, because we'll repeat these steps when we're dealing with polynomials. Once we have our number written up top, 6, we multiply by the 7, 42. Then we subtract 1, and then you bring down the 9. And you start all over. So we did 6 times 7, we subtracted, and then we brought down the next digit. Now I start over. 7 into 19 is 2 times. Then I multiply 2 times 7, which is 14. Subtract 5. Bring down the 2 and start over again. 7 into 52 would go 7 times. 7 times 7 is 49. Subtract, and you have 3. In elementary school, there's usually 3 different ways you learn to deal with remainders. You could put 627 R3. You could put a decimal after the 2 and fill in zeros and keep going and make it a decimal number, or you can make it a fraction, the remainder over what you're dividing by. And that's how we'll be writing remainders for these polynomials. So now for the polynomial division. 2x squared minus 7x plus 4 divided by x minus 2. When you start, you only look at the x and you only look at the 2x squared, and you think, what do I multiply x by to get 2x squared? And that would be 2x. And I like to write it above the other x to the first power and keep everything that's the same lined up. Then, remember, in regular long division, once you write your number on top, you multiply by what you're dividing by. And we'll distribute this 2x. It'll be 2x times x and 2x times negative 2. So that would be 2x squared minus 4x. And then you subtract. But it's very easy to mess up the signs when you're doing this subtraction. The subtraction actually goes to both the 2x squared and the negative 4x. The subtraction distributes. So you have to be very careful. It's really going to be minus 2x squared plus 4x. So the 2x's will cancel, or the 2x squareds rather will cancel, and minus 7x plus 4x is minus 3x. And then you bring down the next number, it's plus 4, and you start all over again. So I look at the x, and I look at the negative 3x. What do you multiply x by to get negative 3x? That would be negative 3. Multiply that out, gives us negative 3x plus 6, and we subtract. The subtraction distributes to everything, so it's really plus 3x minus 6. And when I add, the 3x's cancel. 4 minus 6 is negative 2. That's my remainder. So the way we write the remainder is up at the top we have 2x minus 3, and we write plus our remainder over what we were dividing by. Here's the next one, a to the third plus 27 divided by a plus 3. After the largest exponent, all of the smaller exponents must be represented in the division problem. And if any are missing, you have to fill in with zeros. So let me show you what I'm talking about here. A plus 3 would be on the outside. And then underneath we have a cubed. but we're missing a squared. So we'll write plus 0a squared. We're also missing a to the first power, so plus 0a, and then plus 27. If you don't fill those zeros in, it's going to mess up all the spacing, all the subtraction. So after the biggest exponent, any that are missing need to be represented with zeros. Now I look at the a and the a cubed. What do you multiply a by to get a cubed? That would be a squared. Multiply out gives us a cubed plus 3a squared. And subtract. Distribute the subtraction. So we have 0a squared minus 3a squared would be minus 3a squared. Bring down the plus 0a and start over. Looking at a and negative 3a squared. What do you multiply a by to get negative 3a squared? That would be negative 3a. Multiply that back out. Negative 3a squared minus 9a. Subtract. The negative distributes. 3a squareds cancel, and I have 0 plus 9, which is 9a. Bring down the plus 27. Start over. Looking at a and 9a, what do you multiply a by to get 9a? A positive 9. Multiply out gives us 9a plus 27, and subtract, and this one has no remainder. If the missing term is the constant at the end, you still need to put a 0 in for that. For example, this polynomial 9x to the 5th plus 2x divided by x plus 1. So x to the 5th is largest. That goes first. And then from there down, we're missing the x to the 4th. So it's a 0, missing x cubed, so another 0, missing x squared, so a 0, and then plus 2x. And then we're missing our constant term. So we need to put a 0 in there for that one as well. I'm not going to finish that one. I just wanted to show you the setup. Now, the second method for dividing polynomials is synthetic division. Synthetic division is quicker than long division, and it's usually more error-free. However, synthetic division can only be used when dividing by a binomial. That's two terms. So, to do the synthetic division, just like with long division, missing terms will be filled in with zeros. So in this example, we're missing x to the 3rd and x squared. And you start by the number you're dividing by, x plus 1. You take the constant, which is 1. And I'm going to change the sign and put it in a little box. Change the sign. Hard to read. And then beside the box, I'm going to list all of the coefficients of the other polynomial. Coefficients are the numbers in front of the letters. So it's 3x to the 4th, 0x cubed, 0x squared, negative 1x, and a negative 4. Now, leave some space underneath and then draw a big line. We start by bringing the first number all the way down to the bottom. You multiply that number times the number in the box. 3 times negative 1 is negative 3, and it goes right here. And then you add. So that's negative 3. Then negative 3 times the box. Negative 3 times negative 1 is positive 3. Goes here, and we add. 3 times the number in the box. 3 times negative 1 is negative 3. And add. Negative 4 times the box. Negative 4 times negative 1 is positive 4. And you add. The number at the end is always the remainder. So since this one was 0, this one won't have a remainder. Now to write the answer, we're going to write the numbers that we've just gotten at the bottom. Those are going to be the new coefficients, and you reduce the highest power by 1. So I'm going to reduce x to the 4th. It's going to drop down to x to the 3rd, and the coefficients is this list of numbers I have. So here's how it goes. 3x to the 3rd minus 3x squared plus 3x minus 4. And then that's the answer. We have no remainder. So bump the highest power down 1, and then you have all your coefficients in a line there. Let's try another one. Synthetic division is to find the values of functions. This says use synthetic division and the remainder theorem to find the value. F of x equals x squared minus 7x minus 551. And we're to find f of 29. Well, always before when we did this, we just plugged the 29 in everywhere we saw an x and simplified it down. This is just another way to do it. It's kind of interesting. So the 29 is the number that goes in the little box, but you do not change the sign. You leave it alone. And the coefficients are 1, -7, and -551. Now the synthetic division, the 1 comes down to the bottom. Multiply by the box, which is 29, and add, that's 22. And then 22 times 29 is 638. And add 87. Whatever your remainder is the answer. So with this polynomial, f of 29 equals 87. I want to divide x to the 4th minus 3x cubed minus 5x squared plus 6x minus 3 divided by x minus 4. So my number that goes in the little box is the 4. You change the sign, so it will turn into positive 4. And then the coefficients, 1, -3, -5, 6, -3. Leave some space, draw a line. The first number drops all the way to the bottom. Multiply by the box and add. So that's 1. 1 times 4, 4, and add -1. -1 times 4 is -4, and add. 2 times 4 is 8, and add. So 5 is our remainder. My highest power at the beginning was x to the 4th, so I drop down 1. It will start with x cubed. 1x cubed plus 1x squared minus 1x plus 2. And then you write the remainder like we did with long division, plus the remainder over what you were dividing by. One interesting thing